Hello everyone, so for this video, this is going to be a workshop on the second phase of data analytics. So make sure you read or watch the video on the data analytics lifecycle and the video on quality data and what you do for data processing or cleaning. And at the same time, I'm also going to demo this tool right here, Orange Data Mining. So before showing this, by the way, let me show you how you can download this one as an instructions in video. So Orange Data Mining is an open source software, so it's free as well, and you can just look up Orange Data Mining or go to their official website right here, orangedatamining.com. It will lead you to this one, and then the first thing that you'll see is this download button right here. It will take you to this page, which will give you instructions on how to download it based on your device. So if you're using Mac, if you're using Windows, if you're using Linux, for example, you can install it using the Anaconda version. But most of you would probably be using either Windows or Mac. You can just use any of these applicable links right here. So I would recommend, if you're using Windows, you can just use this one. For example, it will download the installer in your device and just install that one, and it would give you instructions on Orange Data Mining. And when it is successful, it should give you this app right here called Orange, and if you open it, it should take you to this screen right here. So I already gave it this title for now, so there you go. So what Orange Data Mining does, it basically does a lot of the things that Excel does as well. It does a lot of data processing and data transformation things it can do, and it can also do some advanced stuff as well with its modeling, with its visualization. You can have regression models here, you can have visualizations here. You can import data sets using this one, for example. But its main focus is to show the flow of how you work on data. So data starts as a CSV file, for example, and what transformation are you going to do to that CSV file until you reach a usable data set, for example, or until you reach a specific visualization. So in some cases, it has some interesting things that it can do that Excel or Google Sheets can't do, but in other cases as well, there are some things that you can do in Excel or Google Sheets that you can't do here as well, because they have different focus. I'll show you some of them right now. So the first thing that you're gonna need to do is to import your data set. So the data set I'm gonna be importing is this data set called the Cafe Sales data set for dirty data, or for cleaning training. So this is a data set that you can find in Kaggle, and it gives you this information right here. So this is not real world data, it's basically just generated by someone, and it's really meant for training and how to clean bad quality data. Specifically, this data set right here has a lot of missing values and a lot of invalid values, and the objective is to use this data set to train yourself on cleaning data. So the page itself even has some instructions on what you need to do. And the dataset looks like this. So it has transaction ID, which would be its index, and each row in this dataset right here would refer to a transaction in the coffee sales. So this is very similar to the coffee sales dataset that I showed in the previous video, but this one is specifically made to be bad quality. So the possible items that a transaction can have based on what the person bought. So coffee, for example, and then you can buy more than one unit of coffee. So the quantity feature would refer to how many units of this item did they buy. And then the price per unit, which would be in US dollars, for example. It did not indicate here that this is US dollars, but I think it says here that this is US dollars. But it's not really important. So the price per unit, and then the total spent, which would probably be around 2 times 2. So 2 units of coffee for $2 each, which would give you $4 in total. It has payment methods as well, so credit card, cash, etc. The location on where they bought this, it's either in-store or takeaway. I think those are the 2 possible values. And then the transaction date, when they bought this or when the transaction happened. And if you notice right here, if you look at all of the individual samples with individual rows, a lot of the rows have missing data. So row number 2 is complete, row number 3 is complete, row number 4 it's missing the total spent. And the missing data right here can come in many forms. Some of them would come up as invalid data. It will come up as error, for example. Some of them will come up as unknown, and some of them would be entirely blank. And if you get this data set as an analyst, this is not ready for any insights yet. Because if you're going to do some, let's say some descriptive statistics, then your program would most likely be unable to calculate the mean, for example, because a lot of the data is missing. So the objective of the second phase of data analytics, which is data processing or cleaning, is to basically improve the quality of this data set right here. Basically to make sure that all of the missing data are handled, all of the obvious errors are handled. For example, if there are duplicates, you would also handle them, and etc. Okay, so let's begin here in Orange. So you have 2 choices here. If you're going to import the data set, you can either import it using the CSV or the file import. So the data set is already in a CSV format, so you can use this one right here. So you can just drag one of these and it will end up becoming what is known as a widget right here. So every node that you see right here is known as a widget. And you can double click this one and it will give you some options on that one. So since this is a CSV file import, the options would be which files are you going to import here. So you can just click this folder icon right here and it will lead you to the documents or wherever folder it is. And you're going to look for the data set. So what you're going to do, you're going to download this data set right here from Kaggle using this button right here. Download this as a zip. And it will download there. And if I check this one right here and extract this, it will give me this dirty cafe sales.csv. And this is the CSV file that is going to be imported in Orange. So let me do just that. So it was in my downloads folder. Well, let me do it in a different screen. There you go. Here, where I extracted that folder, Dirty Cafe Sales. So select this one right here. It will give you a view on what the data looks like to make sure that you are importing the correct thing. And if you press OK for this one, so let me just look at the stuff here if it's correct. Yep. It will import that one. It will give you here some information. So there are 10,000 rows that would refer to the number of samples in this data set, 6 features and 2 metas. So the metas right here are basically columns that do not represent any feature information. What Orange Data Mining does is it will basically automatically figure out which one of those columns are features, which one of those columns are non-features. So for example, an index, it's not really a feature, so it would be considered as a meta feature. And right now, if you want to view this data again, you can create a new node. So the node for viewing the data would be a data table. So you can drag this node right here. And you're going to connect nodes together. So this is basically the crux of Orange Data Mining. So the CSV file import, I want that to be viewed in a data table. So this one is known as signal propagation. So the output of a CSV file import will be sent through the data table node as a signal. And if you mouse over the node, it will give you what inputs and outputs it expects. So CSV file imports don't have any inputs that it expects, but its output is some form of a data or data frame. And that is exactly what a data table needs. It's looking for data or data subset. And if you double click this one, it's going to give you a view on the data set. And you can see these columns right here that are highlighted green. This would refer to the meta features that are not used for analysis. Basically, you're not going to use that for statistical analysis. It's just for meta information, like the transaction ID right here, which is supposed to be an identifier or an index of each of your samples. The transaction date, for some reason, the CSV file import automatically labeled this as a meta attribute. And the reason for that is because it is not able to figure out the correct data type of this column. And if it can't figure out the correct data type of this column, it is going to automatically convert that into a text column. And a text column will be automatically be considered as a meta column instead of a feature. And that's what it did right here. That's why it's highlighted green. And the reason for that is because there are a lot of missing values. The missing values would basically prevent the software right here, Orange Data Mining, to treat this as an actual date. Instead, it just treats this as regular old text, because not all of these values in these columns right here are data. Not all of them are date values. Some of them are text that says unknown. That's why it is unable to automatically detect this as date. So if you really want to force Orange right here to consider this as date, you can change the data type of that one. Let me try it here. I'm not sure if this will work. I can try going for what is known as edit domain. This node right here is for editing values or editing columns. I think it's in transform. Oh, it's not there. Edit domain. So if you can't find it, you can always use this filter right here, edit domain. There you go. And I will send the signal from the CSV file import right here towards edit domain. And here you can see the data types of each of the columns in your data set. Item right here is categorical, quantity is categorical, price per unit is categorical, and so on. And you can even see here all of the unique values in each of the features. So the items' unique values are cake, coffee, cookie, error, sandwich, unknown, etc. And then quantity. So this is supposedly a numerical variable, but since some of those values are error and unknown, Orange Data Mining will automatically treat this as a categorical variable, because again, some of those errors are not numerical. If you want to force it to be numerical, you can try it here. You can change the data type into numeric, and it will say right here it is reinterpreted as numeric. Price per unit, if you want this to be numeric, then you can force that to be numeric. And then total spent, this is still not numeric, where it is supposed to be numeric. So I will change that into numeric. Payment method, this is meant to be categorical, so you can keep that categorical. Location right here is supposed to be categorical, so we can keep that to be categorical. This one right here, transaction ID is text, that is okay. Transaction date, I want this to be a date, so time, for example, we'll try to reinterpret that as time. And then once we did all of those changes, I just need to press this apply right here, and then that should work. And I'm going to change the input of this data table right here. I will remove this line right here, remove that signal, and then change the pathway right here so that whatever is in the CSV file import, it is going to be placed into the edit domain node. Basically, it will be edited, and whatever you edit to that, you're going to send those signals into the data table right here. And now your data set will now be converted. Their data types will now be converted. So there you go. And here in the data table view as well, you can see some information about missing data. So in your 10,000 instances, or in your 10,000 rows or samples, you have 6 features and 2 meta attributes. It still treats this one as a meta attribute as well. And 12.8% of those are missing data in your 6 features, and in your 2 meta attributes, 2.3% of those are missing data as well. So it will basically give you an information on what are missing. So just to compare what the edit variable did, let me send the signal for this one again and then create a new data table. So there are 2 ways for you to add widgets in your canvas right here. You can add a widget using the tools right here, the widget section right here on the left hand side, like by dragging it this way. I think by clicking it once, it will also create it for you. But another easy way to do that is to drag a signal from another widget. So for example, from CSV import, if I want to connect this to a new widget, I will drag this and then let go. And by letting go, it will give me a choice on what widget I'm going to place right here. So let's say I'm going to place a data table in here just to compare the 2 different data tables. If you look at the 3rd row right here, the total spent is error for this data table. If I compare that to this data table right here, let me restore original order to give it the original ordering again. That was the 3rd row, I believe. The total spent, which was originally error, it is now question mark, because error is not a valid numerical value. Any invalid numerical value will be treated as missing data at this point. So just to review. So the 3rd row, total spent, which was originally error, but after editing the domains, editing the data types, it will now display instead of error as question mark. Again, because any invalid value will be treated as question mark or missing data. That's why when you look at the proportion of missing data right here, it looks like the missing data increased. So originally, 11% was detected as missing data before editing the domain. But after editing the domain, it looks like it increased. That's because it is also able to detect all of the data that was labeled error and unknown as missing data as well. So it is able to properly tag actual invalid values as missing data, which is what you would want. So you can also change the names of these widgets as well. It would make it easier for you to track what's going on. So if you just create a node, it will basically create a node with a default name. So the data table (1), the data table edit domain, and then CSV file import. These are basically default names. If you want to give it your own name, so for example, if I want to change this, you can right click a node and it will give you these options right here to either duplicate it, remove it, or what we want, which is to rename it. It also has a shortcut right here, which is F2. And oops, sorry. Let's rename this one. So I can change this to change data types so that I know what this edit domain is doing. And then I can rename this again to change data types. And I can rename this, for example, into, let's say, raw data, where nothing has changed. There you go. Okay. So the objective of, again, data processing or cleaning is basically to get rid of all of these invalid and missing data, and depending on what strategy you're using. So if you have read the lecture notes for data processing or cleaning, so you have two choices on what to do with the missing data, and you can decide based on the impact. So you can either remove the rows which contain the missing data, you can remove the columns which contain the missing data, or you can impute those values, basically replace them with a representative value. And the choices basically depend on you as a data analyst, and there's no one-size-fits-all choice for all of these. It depends on the context. In some cases, you would want to remove the rows. In some cases, you would want to remove the columns. And in some cases, you would want to impute those missing values. You just have to figure out which of those choices would have the least impact for your data set. Okay, so let's inspect first the missing data on what it looks like, how much of the data is missing, and which part of the data set is missing. So what I'm going to do right now, I'm going to display one of the limitations. Sorry, I'm getting off a little bit of a tangent. One of the limitations though with your with Orange data mining right here is that if data is missing right here, it doesn't have a lot of options on how it handles that missing data. If I'm correct, with the missing data right now, the only way you can remove that is through this node right here called impute, which would basically give you choices on either to replace those values or to impute those values basically. And we don't want to do that yet. What we want to do first is to inspect what the impact of replacing those values would be. How many rows would be missing if I remove that? If a given row has a lot of missing values, or are the missing values only rare, for example, for every row? So I want to basically get a picture on what the missing values look like. So what I'm going to do right now, I'm going to delete all of these nodes first. I'm going to start a new. So instead of importing it via CSV file import, I'm going to import it using a different way. I'm going to import it using the file import way. And it will basically give me a better control on the data types of these imports right here. So I already imported this a while ago, so it will already given me these choices. But you basically go through the same process with the CSV file import. You basically click this folder icon right here, which will lead you to a choice on which file to import. So this is the correct file to import, is dirtycafesales.csv. And this one right here will give you more choices on what to do with each of the columns. So for example, if I don't want my transaction ID to be treated as text, I can change it to categorical, for example, and then change it to a feature instead of an actual meta feature. But I do want that to remain as text for now. You can also even skip. If you don't need these columns to imported, you can select skip, for example. But I do want to keep all of them, so I will click meta for transaction ID, because the transaction ID will be treated as the indexes for each row. And then quantity right here, instead of text, I want this to be categorical right now. Supposedly quantity again is numerical, but because it has missing some values are labeled as unknown or invalid, it will be automatically treated as categorical. There's no way for you to treat this as numerical right now. But again, you can always change the data type later using the edit domain. So I want that to be categorical, and I want that to be an actual feature instead of a meta feature. I want to do the same for price per unit as well, categorical and then actual feature. And then transaction date as well, I want that to be categorical and feature as well. Again, these are not the proper data types right now. Once we deal with the missing values and the invalid values, we can safely convert them into the correct data types, into numerical or date, for example. So I'm going to apply this one right here. It will basically give me a warning. Categorical values with more than 100 values will decrease performance, but since this is a warning, you can ignore this. It will basically tell you that it will basically slow down the software, but it doesn't matter right now. I do actually need to do that. So now that I've applied it, I can close this one right here, and I can view this again using the data table widget. And I can open this one right here, and this is the correct data set, yes. And if you notice, transaction ID is labeled as green because this is the meta variable, or the meta feature, sorry, that refers to the index of each row. And the transaction date right now is not labeled green because I've now forced Orange Data Mining to treat this as an actual feature instead of just random text. So that's why we're using this general file import instead of the CSV file import a while ago. So I'm going to rename this one just to make it easier for me into raw data. Basically, there are no changes for this data right now, so it's considered raw. Okay. So the next thing I'm going to do, I'm going to go through file import, into edit domain to change some of the values in all of the columns. So I'm not going to change the data sets, I'm not going to change the data types right now. I'm just going to change the values right here. Before that, let me redo that again. Before editing, I'm going to go through impute first to handle all of the missing values first. Okay. Oh, sorry. This is so confusing because I'm going back and forth. That was actually correct. I need to go through edit domain first. And what I'm going to do, I'm going to create a new value for each of these categorical variables right here. And using this button right here, this plus button, I'm going to add a missing value. So all caps missing. So that's going to be used later for the imputation. I'm going to do that for all columns right here. Missing. This one as well. I'm going to create a new missing value. So I'm not actually creating new rows, new values, or new samples for my data set. I will basically tell Orange right here that I'm giving all of these features new possible values. I'm going to show you later what this does. I'm going to go scroll down all the way here. Then I don't need to do that for this one since this is just an index and there are no missing values here anyway. I know that there are no missing values right here because in the meta attribute there is no labeled missing data right here. So I'm going to rename this into create missing tags. And I'm going to go to a new widget right here in the impute widget. And the impute widget basically allows me to handle missing values. And it will basically give me choices on what to do. So either to impute those values or to delete rows that are containing those missing values. And I'm going to use this to basically replace the missing values here with the missing tag that I just created using the edit domain. So in each of these features right here, item, for example, it will give me choices on what to do. So right now, there's our default methods right here on what you want the handling of the missing values to be. So this will basically, this right now set into don't impute, basically ignore any missing value. This is the default handling of any missing value for any feature. But you can also specifically change what to do for a specific feature. And you can do that by selecting one of the features right here and then select all of the choices right here. So for item, what do you want to do? Do you want to leave it alone using the default that is stated right here? Don't impute it, which is basically leave it alone as well. Replace it with the average or most frequent value. Replace it with a distinct value. Replace it using a model-based imputer, a random value, or remove that instance with unknown values, or replace it with a fixed value, which is what I want. I want to replace the missing values in this feature with the missing tag I've created. So the missing tag that I've created will now appear here in the list of possible values to replace it with. And that is only possible by using this widget right here. Without creating this create missing tags widget, the missing values won't appear here. So there you go. And I'm going to replace all of the missing. I'm going to do the same for the other features as well. So total spent feature as well. I want a missing tag for the missing values. And then the payment method, I want a missing tag for the missing values. For the location, I want the same as well. For quantity, I want the same as well. And then for price per unit, I want the same as well. And for transaction date, I want missing as well. So I'm going to need to scroll all the way down. There you go. And this will basically give you as well how many possible values are there now. So item now has 10 possible values. Total spent now has 19 possible values. Payment method has now 5 possible values, and so on. So I can close this now. And then if I view what this looks like, all of those missing values are now replaced with the missing tag right here. So just to show, let's remember that we're looking at row 9 for the feature item, and let's compare that with the raw data right here. Row 9 for the feature item right here. Before doing this process right here, this was labeled as question mark, but after doing this process right here, it is now labeled as missing instead. And that's basically what I want. The next thing I'm going to do, I'm going to go through the create domain again. So here, what I'm going to do to basically create a uniform way of expressing missing values, all of the other invalid tags, I will also replace them with missing as well. So the error tag right here, the error values, I'm going to replace them with missing. And then the unknown tag, I'm going to replace that with missing. So what I'm doing right here, this screen, what you're looking at right now, is basically a replacement. So every time Orange would see a value cake inside the item feature, it will be cake right now. Coffee will be coffee, still coffee, cookie would be cookie. But what I edited right here, if it ever sees a value that is labeled error, I will replace that with missing. And then if it ever sees a value that is labeled unknown, it will replace that with missing. And then missing will stay as missing. And you see right here, there's a parenthesis merge right here, which will basically tell you that all of these values, error, unknown, and missing, are now merged into the same value, which is missing. So that's for the item data type. And I need to do that for all features as well. So the total spent, all of the errors will be replaced with missing. Make sure you write the same spelling and the same capitalization right here. Need to do the same for the payment method as well. Missing, missing, missing. And again, I'm doing this so that there's a uniform way of expressing missing values for all features, because some of them right now are labeled as error, some of them are labeled as unknown, and I want it to be uniform. I want it to be consistent. Price per unit as well. this one would be missing, and then this one would be missing. So just review that I did the correct thing. Everything is missing, 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 merge into missing. And see here the apply button, the text inside the button is now italicized. It means that I need to press this to apply all of my changes. And then there you go. And just to view this one, I create a new data table right here. So if you notice, there are no error values or unknown values. All of the missing values are now labeled missing, which is now uniform. If you notice right here, there is no missing data according to Orange Data Mining. I mean, it thinks that there is no missing data, but actually we just replaced all of the missing data with the tag missing. There you go. So I'm going to rename all of these widgets as well to tell me what I did right here. Replace unknown and error. Actually, that was all caps unknown with missing. There you go. Then this one renamed to missing data. There we go. By the way, these data tables are just views, by the way. You can actually remove them if you want, but I'm gonna keep it right here so that I can always go back to the previous versions of the data sets. Okay, so the reason why I made a consistent way of tagging missing values is because I want to basically graph or create charts that will basically tell me what proportion of my data is missing. So you can use all of the built-in visualization methods right now. So for example, I'm going to create here a distribution chart. So let me change this first, this signal. Instead of sending the selected data, I want to send all data right here. So what you're looking at right now, this is basically editing the signal that is being sent from one widget to the other. Because one thing that you can do, instead of sending the entire data set, you can just select a few rows out of it. So for example, just all of these. You can select from row 1 to row 14, for example. And instead of sending the entire data set, because this one is labeled selected data, what's going to be visualized right now would be the selection right now. But if you don't want that to happen, you can either select everything, for example, or you can simply change the signal right here from selected data into the entire data set, like that. So this will give you the distributions of the missing values for each of the features. So for example, for the selected, actually this feature right here is created because of the selection right now. Let me actually remove the selection. Just ignore this feature right here. This is just created because we created a selection a while ago. So what we're concerned with are these features, the item feature. So if I expand this to see all the items right here, so this is the distribution of the different values items could have. Some of it has the cake value, some of it has the coffee value, some of it has the cookie value, etc. What we're concerned with is how many of those values are missing. And right now, 969 of those values are missing. in total spent, this one, 502 of those values are missing. Here, this is a big proportion, bigger than the rest. 3,000 of the 10,000 are missing. And then location, 3,961 are missing, and so on. So this will basically inform you if you want to decide on, let's say, deleting an entire column. For example, the location feature right here, 3,000 of the 10,000 values in the feature column is labeled as missing. So if you think that you don't really need the feature location, the location feature, then you can decide to delete the entire column. So these are some of the decisions that you can do. And you can do those decisions by basically inspecting the proportion of the missing values. Not the entire proportion of the missing values for the entire data set, but looking at it by each specific feature. So here, transaction date, 460 are missing out of 10,000 as well. So it looks like a lot, but because there are so many possible values for transaction date, that's why this one looks like a really big proportion. But you want to look at the amount, so 460 or 4.6% out of the 10,000 possible values. Okay, so I'm gonna keep it here. So these are basically a way for you to see the distribution of missing values for each column. I'm gonna rename this as such. Distribution of missing values for each column. There you go. I also want to see the distribution of missing values for each row as well. So this one will be a little bit more complicated because this will require some formulas, but you can just follow along right here. So similar to creating formulas in your Google Sheets, you can also create formulas as well in Orange Data Mining using the formula widget. So from this data right here, I'm going to create a formula. And the formula syntax that you're going to use will not be similar to Excel or Google Sheets. It's basically using Python syntax because Orange Data Mining is written in Python. So what I'm going to create this numeric feature right now. I'm going to name this new feature or variable. I'm going to call this missing. And I'm going to use this formula right here. 1 if, let's go for the item variable, is equal to missing, else 0. So what you're looking at right now, is basically Python code. And this is basically an if-else statement that says that if the value of what is in the item column is equal to the missing tag, then this one will receive the value 1. Otherwise, if it is not missing any other value other than the tag missing, it will be treated as 0. So let me send this right here and then see what happens. So view the data table again. So again, that was on the on the item feature. So for example, row number 7 right here, item is labeled as missing for row number 7. So in the missing column right here, this value will receive 1. If it's not missing, any other value will change this to 0. So here, if the value is coffee, cake, cookie, salad, coffee, smoothie, all of those are not equal to missing, so that will be replaced with 0 instead of 1. This one is 1 right here because here in the item column that is labeled as missing. This one in the item column, row number 15 is missing. So if you look at the column we created right here, this is labeled as 1. So that's what the formula we created. So what I'm going to do, I'm going to create the same formula right here for all of the features that I'm concerned with. So I want to do this as well with, let's say, the feature. Let me copy this. And then replace this with, let's say, total spent. So this is just the same formula, but instead of using item, I'm using total spent right here. So 1 if total spent is equal to missing, otherwise 0. And then this entire value right here is added to the original value before. Okay, so what does this do? Let's look at it. So here, this one has a value of 2. Not sure if that is clear. So this one has a value of 2 because if you look at the item column, sorry, let me properly select them. Oh, my bad. If you look at the row number 32, the item feature is labeled as missing. The total spent feature is labeled as missing. Therefore, instead of having a value 0 or 1, it now has a value of 2 because we're adding the 1 from this column and then the 1 from this column. And what this will give you, it will give you a count on how many of these two features right here are labeled as missing: total spent and item. This one, row number 33, smoothie and 16, those are the values for item and total spent. Neither of these two are missing, so this will have a value of 0. On the other hand, the row number 34, only item is missing, total spent is not missing, so meaning you only have a value of 1. So that's the reason why I created that formula right there. And I'm going to do that for all of the features that I'm concerned with, or basically all of the features. So I'm going to add, instead of total spent for this one would be payment method, and then add, instead of total spent for this one, location, and then add Control V. Instead of total spent for this one, I'm done with payment method. I think it was quantity, and then add, instead of total spent right here, I want this to be price per unit. And then finally, the last one, this one should be transaction date. There you go. So this is a really long formula, but you can just copy this one. What this formula does, it basically counts how many of these values are missing. So this is one of the limitations of Orange Data Mining. If you're doing this in Google Sheets or Excel, for example, counting the values labeled as missing would be much easier than this. So that's why, as much as possible, you would want to learn both of these tools, because there are things that Orange Data Mining is good at that Google Sheets would not be good at, and the reverse is also true. There are things that Google Sheets is good at that Orange Data Mining is not that good at, and this is an example of what you're looking at right now. Orange Data Mining is not really good at creating formulas. Its formulas are limited. So here, by the way, every time you do changes in the formula, you basically need to press this send right here to send that signal. And if you want to rename the column, you can just replace this name right here, number of missing. There you go. And press send again to apply the changes. And if I look at this one, I now have this number of missing features right here, which would refer to the number of missing feature for each column. So row number 1, how many missing values here? 0. Row number 2, how many missing values? 0 as well, but here, row number 3, the number of missing values are 1, and if you do count them, 1 missing. Row number 4, there are 2 missing according to the missing column, so 1, 2, there you go, it's correct. So I created that new feature right there to basically give myself a way to display missing values or count missing values. So I can rename this one right here and to data with number of missing. Can rename this right here into count number of missing values per row. There you go. And now that I did this, it will basically let me create some charts for it. So for example, I will create this bar plot right here. Let me not do that first. Let me create this distributions first. So here in my number of missing distributions, so this is the amount of rows that have less than 1 missing value or 0 missing values. So 3,089 of them have no missing values. 4,285 of them have 1 missing value. 2,136 of them has 3 missing values, and then 439 of them has 4 missing values, and then 47 of them has 4 missing values, and finally 4 of them has 5 missing values. Wait, this looks kind of weird. The bar chart is not displaying the correct heights for some reason. Oh, I think it's because it's a cumulative distribution. Sorry. Let me uncheck this one. Okay, so I accidentally checked this cumulative distribution checkbox right here, which will basically add all of the successive values together in a cumulative way. So you don't want that to this if you want to get the value for each. So again, so just to show everything again, so this is a bar chart of the number of missing values for each of them. 0 number of the number of rows that have 0 missing values is this amount. The number of rows that have 1 missing value is this amount, and so on. And this will basically give you an impact. For example, if you want to know how many of your rows would be deleted if you remove every single missing value. So only 3,089 rows have no missing values, and that's basically the amount that you're going to be left with if you delete every single row that contains a missing value. But if you don't want to delete all of them, let's say you only want to delete the rows that has 2 or more missing values, for example, then you're going to be left with this amount plus this amount. So that's actually, the cumulative distribution would actually be useful if this was in reverse, but it's not. Basically add these two together, so 3089 plus 4285. So that's the amount of rows that you're going to be left with if you delete rows that have 2 or more missing values. So if that amount is acceptable to you, then you can do something like that. So let's say, to me, that's acceptable. So let's say I'm going to replace this with distribution of number of missing values per row. Okay, so this tells me that if I delete all of the rows that contains 2 or more missing values, I'm going to be left with around 7,000 rows, which is acceptable to me. That will probably be enough. So let's do that. To do that, we can use this widget right here called select rows. And if you open this one, it will basically give you a condition. And if a row passes that condition, then it will be selected. So for example, I want the number of missing to be is below 2. So if the number of missing is below 2, then that row will be selected. So let's close this one. Actually, it will give you here how many of the rows will be selected. So 7,374 will be selected. 2,626 will not be selected out of the 10,000. So the matching data right here, 7,374, the unmatched data, 2,624. That will basically tell you that you're going to be left with 7,000 values. I'll close this one right here and then create a new node for the new data table right here. It's getting quite crowded in my canvas. I'm going to move everything to the left right here to give me more space. So if I view this one, I only have 7,000 rows right here, but all of the number of missing right here are either 0 or 1. I don't have the rows that have a lot of missing data. I basically discarded all of those at this point. Pretty cool. So I can change the names for this one. Rename this into select rows with at most 1 missing values. This one will be renamed into data with at most 1 missing value per row. Okay. So if that is the acceptable amount of rows that I will delete, I'm now able to decide on what to do with the remaining missing values, because we're not done yet. The values are still missing right here. And I need to find a way to replace these missing values with either a replacement or something else, because I decided to keep these values right here to be missing. So I need to find a way to replace this with, again, an imputation or a replacement value. So to do that, you can now use the imputation. Oh, but before that, the imputation only works with missing values. So you will revert the values tagged as missing into actual missing values. So to do that, you will go back to the edit domain again here. So I think I also did the same thing again because I selected some data. I only selected one row instead of the entire thing. This one. I want to select the whole thing, so I will replace this one with the entire data signal right here. There you go. So to actually remove the missing values and replace them with actual missing values, I'm just going to delete this one right here using this minus button, or you can use the delete button on your keyboard. So it will basically drop that value. It will not remove the column, it will just basically drop the value itself. It will now be a missing value, which is what imputation, which is what the impute widget can work with. This one will be deleted. I'm using the delete button on my keyboard, by the way. This one will be deleted. I think it's all the way in the bottom. This one will be deleted. This one doesn't have any missing values because this is numerical. Then this one, I can just ignore this. This is just because of the selection from the select rows widget. Okay, apply everything. And if I view what this data looks like right now, so all of the values labeled as missing will now be replaced with a question mark. And this is where imputation can now be used. Let me label this. Let's rename this to revert missing to question mark, or to actual missing values. Data with question marks instead of missing. There you go. And this is where imputation can now be used. Let me move everything to the left again to give me some more space. And go to the impute widget. And again, we're going to deal with, we're going to decide on what to do with the missing values right now. So for the item column, what do we want to do for that one? Let's say we want to replace it with the most frequent, or the average, basically the mode. So if the most frequent value in your data set is cake, then all of the missing values will be replaced with cake. But you can also do something else instead. You can also replace it with other, for example. But since we decide to impute it, let's replace it with the most frequent value. The total spent, it will be, let's say, replaced with the average value. Or sorry, I think I found a issue, by the way. I also need to change the data types back into numeric. So right now the data types are all categorical. But since I've now replaced all of the tags missing with actual missing values, I can now safely change the data types. I can also do it here directly, replace the data type right here. But just to make it clear, just to make it more step by step, I'm going to separate it into its own widget, this particular edit right here. So item should stay as categorical. Total spent, I want this to be numeric. Payment method should stay as categorical. Location, categorical. Quantity, I want this to be numeric. Price per unit, I want this to be numeric. Transaction date, I want this to be time instead. So time for that one. And then select apply. So they're now in the correct data types. I can now impute. If I just pressed impute without changing the data types, then I won't be able to replace it with the average, for example, because in the imputation widget right here, if it sees the feature as categorical, then it's going to impute it with the mode or the most frequent value. But if it's numeric, it's going to impute it with the average value. There you go. So this is numeric. This will be correctly replaced with the average value. Payment method, I want to replace that with the most frequent value. This one as well, then this one, and then this one. Then this one, you can replace this with either, for example, a random date. Oh, it doesn't work for random values. A distinct value, for example. You can also impute them as an average value na lang. This one also average value. But since we just did all of these, you can also just replace the default method, for example. Since you're gonna replace everything with average as well, you can just do average for all of them. This one again is just from the selection. We can just remove this column later. This is for the selection of the rows widget. So let's rename some of these. This is changing data types. This one is impute with mean or mode. And if we look at our data, then there are no missing data anymore. So just to compare it with what it looks like before the imputation, 7.3% of the data was missing. On the other hand, this one has now no missing data at this point. So if you want to remove this selected column right here that was created because of the other widgets, you can use the select columns. It will basically give you choices on what to do. This one right here, if you want to ignore it, you can put it in ignore, for example. This one, if you want to keep it, you can keep it as a meta variable. And then there you go. There are no missing data. So if you look at the replacements right here, in row number 3, it's pretty obvious that this one is a replacement value. So the average or the mean total spent value is around 8.9. So that's what the missing value is replaced with. It's obvious that this is a replaced value because the original values for this one don't have any decimals. So we kind of know that this is a replacement. Let's look at the other data types. Let's go back here. So for example, in row number 6, the location is question mark, and in row number 5 as well. Let's look at here. Row number 6, location is now both in-store because let's say in-store is the most frequent or the mode of the location value. And that's basically it. So after you watch this video, what you can do, you can try to redo what I did. I'm going to post this as well. You should be able to find this in the my portal as well, this file right here that you're looking at. You can open this in Orange. But if you want to practice doing this as well, after watching this video, you can try to redo what I did. You can follow along with the video or whatever, but yeah. If you have any questions and if you're stuck somewhere, for example, if there's something confusing with the tool right here because it's the first time, you can ask me questions. I will also post some tutorial videos created by Orange Data Mining themselves, but I'm not sure if those videos are as updated as possible, but I'll post a link of that one in my portal as well. Thanks everyone. Oh, before I do that, if you want to save this, by the way, you can just go to File, Save, and then it will save it as an .ows data type. Give it a name, for example, coffee sales data cleaning. Save that one, and you can reopen that later. So just to show what we ended up with. So again, this is what Orange Data is good at. It will basically give you a history of what we all did to reach the cleaned data, for example. This one. So to end up with this data right here, this is what we had to go through. And you can go back to the previous versions of the data set. You can go back to the visualization we used to make decisions, and so on. And that's really finally it. Thanks everyone.